All right, guys. So today I've got an interesting one. This was a real head scratcher, and it kind of threw me for a loop. But once we figured it out, you got that great satisfaction feeling. Okay. What I want to point out is that you can't just always assume that the first problem you find solves what's going on. Okay. We're going to be looking at an ice machine right now, and we found a major problem right from the get-go. And it took me a few minutes to find this problem too. Okay. I was doing my ice machine paper where I write down all my pressures, and I was noticing that we had high suction pressure but normal head pressure, but we had really long freeze cycles, and we were going off on a 3 beep, or I think it was a 3 beep long, whatever the long freeze backup timer on a Hoshi machine was, and it was causing them to constantly have to reset the machine. And they'd had their techs out at this particular this particular hotel chain. They had their restaurant out, or their techs out, and they couldn't figure out what was going on. It was a real, and I'm not knocking anybody. This was a very complex problem. But what happened was a few steps were skipped in someone's diagnosis, and they misdiagnosed something, okay? And you guys are going to see what I think happened at the end of the video, and then we'll do a recap and talk about it too. All right, when I'm working on ice machines, I like to take a notepad and write down the refrigerant pressures, okay? I was working on a Hoshizaki ice machine, and if anybody knows anything about Hoshizaki machines, they have in their tech specs book, they have the recorded pressures at 5 minutes into the freeze cycle, but I like to go above and beyond. It does a couple different things, but it helps me to observe the machine while it's operating and start to see trends and notice things that are happening. So anybody that's paying attention to this sheet right now, they may be able to understand some of our scribble, but this machine obviously has a really long freeze cycle. Okay, so what I do is I start with a 2-minute mark, 4-minute mark, and every 2 minutes except for I note the 5-minute mark when I'm working on a Hoshi, okay? So Hoshizaki ice machines, just depending on how warm it is and stuff, you're gonna be like 28, 29-minute freeze cycle, and then, short harvest cycle in there too. But you notice this machine went all the way to the 36-minute freeze cycle, and actually at that point in time, actually 38 minutes, at that point in time, I initiated a harvest cycle because something was going on. All right, so I'm gonna show you guys on the video right now what happened, but I want you guys to see and understand how these books work too, okay? So you got to pay attention inside the books. The machine that I was working on was a water-cooled machine. So what I do is I keep my notes for myself to review, okay? Model and serial number, and then I have 70-degree water for condenser and for water inlet valve, okay? Because this is a water-cooled coaxial condenser. So the condenser inlet was 70 degrees when I started, and the water inlet for the machine that actually, the consumable water was 70 degrees also, okay? So pay attention in your book. It has all the information you need. Water-cooled head pressure controls, and it tells you all KM models. The temperature range should be 104 to 115 degrees. Should have about 270 psig water or refrigerant pressures, okay? So that's the temperature range coming out, the water coming out of the valve, okay? And then also, I put little notes right here. We'll go ahead and scroll back to the data information. You find your model number right here. Excuse my crude little bookmarks. Find your model number. So 70 degrees ambient temp. And then you find your water. So we're doing a water-cooled machine. And you go down, and I'm looking for refrigerant pressures, and then it asks you what the water inlet temp is for the consumable water, and that was 70 degrees. So my head pressure should have been about 271, and my suction pressure should have been about 52 psi, okay? So let's look at my 5-minute mark. We were at 69 and 261. Something's going on there, right? So I'm going to go ahead and pan on over to the video, and you guys will see what actually happened. And mind you too, I'm monitoring, because this is water cooled, I had my temperature clamps, and I was looking at inlet and outlet on the condenser. So notice we had about 72, 73 degrees the entire time we were making ice inlet. And then notice your outlet temperature pretty much maintained 100, 103 degrees outlet, okay? Now, once I found the problem, those numbers changed, and you guys will see all of that. So we're working on a water-cooled Hoshizaki today, and we just kind of ran across an interesting problem in that this is my outlet, and I've got water coming into it. I've got a cold outlet and a hot inlet. We've got lines switched is what it looks like. So I've got 100-degree, and see your water valve's going out. And that should be our hot line. And they're feeding the wrong direction, I believe. But what's interesting is when did this start happening? They may have just installed this machine here. We're at a hotel, so they have their own people. Okay, so I switched my manifold because what I did was I went ahead and recovered the charge out of this unit. It was screaming. I could tell other people had been working on it. So first off, to recap, we found that the water lines were switched, the inlet and the outlet on the water-cooled system, okay? So they had cold water going into the valve, which hot water should be coming out, basically. So water-cooled coaxial condenser. And my pressures were out of whack. Just didn't seem right to me, and I kind of feel like they have their own maintenance people and they've been playing with it. So I went ahead and recovered the charge and found that it was undercharged. So vacuumed it down, put in the factory charge, and now we're running 77 over 254 for about 7 minutes in, and the head of my compressor is ice cold. So we've got a bad expansion valve. It's overfeeding, and the previous tech probably let some gas out to try to compensate for it. So, and the head pressure was on point because the water regulating valve was regulating it, bringing the head pressure up to where it should be. But then we had a weird back pressure, so yeah, so we weighed in the charge. It's got a bad expansion valve. We're gonna go ahead and order it, let them know what's up, and then we'll come back out. But on these things, you can't just assume, you know, you run into all kinds of weird stuff. And the other thing too, like there was a wire that was just dangling in here. I put a wire net on it. It just, I could tell people have been working on this. It's also pretty crusty inside and stuff, so that's where we're at. All right, so that was an interesting one, right? We had a Hoshizaki ice machine. We had a service call that it wasn't producing very much ice. Okay, this is a small little itty bitty 500-pound machine. And what I found initially when I first got there, after going through my checklist, I happened to notice that the water lines were reversed. Okay, this was water cooled, obviously. We had a coaxial condenser, and we had the warm water coming out the wrong spot on the machine. So the water flow was going the wrong direction through the machine. Okay, that can cause some problems. All right, it's just like piping the refrigeration system incorrect through the condenser. And what can happen is you're not properly changing the state of the refrigerant from a vapor to a liquid the correct way. Okay, so more than likely when I first got there, we were feeding vapor to the expansion valve and it just wasn't working right. Once I corrected the water flow issue, then I found that the machine still wasn't quite acting right and it was low on charge. Okay, you guys saw that I recovered I told you that I recovered the gas and went ahead and weighed in the charge. And then once I weighed in the charge, I noticed something right away. Initially, when I started up the machine, you guys didn't see it in the video, but I had 100 suction pressure, 100 PSI suction pressure. Okay, that's insane for a Hoshi. And then a few minutes after that, the suction pressure dropped down, but then all of a sudden, it still didn't get to where it should be, but then all of a sudden, the compressor head was ice cold, okay? On a Hoshizaki ice machine, that's a dead giveaway, the way that this was cold. I wish you guys could, we had like smell-o-meter or something like that where you guys could, you know, feel what I'm actually seeing out in the field. But this compressor was ice cold, the whole head, okay? And let me step back to the very beginning. One vital sign, again, using my vital signs that I noticed was the compressor head was extremely hot from the get-go in the very beginning, almost to the point that I thought we had a plugged up condenser. Anyways, back to the end. The compressor head was ice cold, really bad, not just around the inlet to the compressor, but the whole head. That indicated to me right quick that we had a bad expansion valve. Okay. Now, what I did do is I did check the valves in the compressor before I diagnosed the expansion valve just to make sure. And what I did was I disconnected the liquid line solenoid valve. There's a little Molex plug you can just unplug and then watch the system pump into a vacuum, shut off the machine, and made sure that we weren't bleeding through from the discharge to the suction side, which would indicate we had bad valves in the compressor. That was not the case. When I pulled it into a vacuum and shut it off, it held the vacuum. Okay. So we knew that was good. So after I did that, that's when I found the head was ice cold. Told me that we had a bad expansion valve. Okay, I have not replaced the valve yet, but I did let the customer know. But this is one of those ones that I really wanted to point out. And I had another tech working with me, and it was a great experience for him because I wanted him to see this problem. Okay, you can't just stop at the water lines in the beginning and assumes everything's okay. We could have left and said, oh yeah, keep an eye on it. And then they would have called us back. All right. I stepped back, looked at the big picture. Okay. And we didn't solve the symptom. We solved the problem, right? The symptom was the weird pressures or, you know, the water lines being swapped. Okay. But the problem was the expansion valve. All right. So my idea was that they sent their tech out there and he didn't quite know what he was doing. And he probably saw that really high suction pressure and he thought that, it was overcharged. So my assumption is that, or he used really, really long gauges because that system only holds 14 ounces. But regardless, when I first walked up to the unit and started to troubleshoot it, it was acting really strange. And even after I corrected the water problem, it was still acting pretty strange. Well, it was because we were low on charge. So once I recovered the gas, vacuumed down, made sure we had no leaks, I weighed in the charge, and that's when I saw the issue with the expansion valve. Okay, so always got to look at the big picture. Make sure you thoroughly evaluate things. And especially if you know other people have been working on it, that's when you really got to get kind of like, okay, wait a minute. And see, I called the maintenance staff, the people in charge, and said, hey, you know, I'm really thinking someone's been messing with this. I don't know what they did. Maybe we have the wrong gas. Maybe, you know, who knows? And so that's why we just recovered the charge and started over. All right. Really appreciate you guys taking the time to watch these videos. This was a really fun one actually for me. Hopefully you guys get something out of it too. And we will catch you guys next time. Okay.